Alright, so let's talk about the terms used in describing atoms. Please, if you're yet to watch the part 1 of this class, please make sure you do before moving ahead with this class. Now, an atom is the basic unit of matter, the fundamental unit of matter, the structure in which everything in the universe is made. So it is defined as the smallest part of an element that can take part in a chemical reaction. We've talked about atom before. Now, this atom is arranged, they are basically arranged into 118 elements that you have on the periodic table, and they have their fundamental use. Now, these atoms, some of them can't exist alone. They can't stay on their own. Like hydrogen atom, you don't expect to have hydrogen atom everywhere. Or an hydrogen atom can combine with another hydrogen atom to form what we call hydrogen gas or hydrogen molecule. Now, this hydrogen gas can exist on its own. Under some certain conditions, it can also react. But this hydrogen gas is what we call a molecule. So a molecule is the smallest part of an element or a compound that is capable of independent existence. Please make sure if you want to write, you can pause the video, then you take a note of all these definitions and you follow the explanation through before we start solving questions. So a molecule is the smallest part of an element or a compound that is formed by chemical reactivities, by joining bonds together. That is, it is capable of independent existence. That is what we are trying to say about molecules. So when you have molecules, depending on the number of atoms that are joined together, you can form your molecule. Join one hydrogen to another hydrogen, that is called a diatomic molecule, which means made up of two atoms. If it's made up of one atom, just a single atom that can stay on its own, when you check most of the group 8 elements, the elements in the group 8 from helium, argon, neon, krypton, xenon, and so on. All these elements can stay on their own without reacting with any other element. So these are called monoatomic molecules. Hydrogen chloride, that is hydrogen reacting with chlorine, is also a diatomic molecule. So when you're talking about molecules, molecules can be monoatomic, depending on the number of atoms joined together, can be diatomic, can be tri, and can be poly. Even up to the complex molecules like starch that we have. Even if you look at your sugar to made up of like this. Let's check this out. This is C6H12O6. So how many elements do we have here? We only have 3 elements: carbon, hydrogen, and oxygen. But when you check all the atoms of the elements that are present in this molecule, they are 22, sorry to say. So there are 22 altogether. Now, when you're looking at a molecule can be mono, that is, for example, the helium, neon, argon, krypton, xenon, and radon. So these are the monoatomic molecules we have. Those are the elements of the group 8 element. Now, when you have the diatomic, we have hydrogen, nitrogen, oxygen, HCl, atoms molecules that are made up of 2 different forms of atoms. They are called diatomic molecules. While ozone is an example of a triatomic molecule made up of 3 atoms. Now, a polyatomic can be an element that can stay on its own but not mono. Look at this. Phosphorus can exist on its own, so it is a polyatomic made up of many atoms. If you have sulfur too, sulfur as well is a polyatomic molecule. So let's just leave this at the basic. There are still complex molecules made up of several atoms, but we call them polyatomic molecules. Now, when you are dealing with ions, an atom can lose or gain electron. When an atom loses or gains electron, they are called ions. So they have a charge. When an atom loses electron, it becomes it carries a positive charge. It becomes positive. When an atom gains electron, it becomes negative. That means whenever you accept electron, it carries a negative charge. When it gives out electron, it carries a positive charge. The positive charge atoms, they are called, or ions, don't let me call them atoms. The positively charged ions are called cations, while the negatively charged ions are called anions. So let's quickly look at this. So when you're talking about ions, so your ions can be an atom that has either gained or lost electron. So when they gain electron, they form anions, anode ions. When they lost electron or lose electron, they form cations. So these cations are positively charged, while anions are negatively charged. Now, you need to note something. When an atom gains electron and forms a charge, what is changing is the electron, not the proton nor the atomic number. We're going to see an atomic number is defined as the number of protons that are found in the nucleus. Now, when an atom loses electron, the atomic number does not change. But when it is in neutral state, the atomic number will be equal to the number of protons and will be equal to the number of electrons. Please note this, because many students used to make mistake when they are talking about this in this case. So let's look at example. When you have a neutral atom we have atomic number to be equal to the number of protons, which will be equal to the number of electrons. But when you have a charged atom, when I say charged, I meant the ions. So I have the atomic number will be equal to the number of protons. That won't change, but that won't be equal to the number of electrons. I hope you understand that. When an atom loses or gains electron, the number of protons remains the same, but the number of electrons will change. Let's take an example. If I have sodium with atomic number of 11, the atomic number here is 11. It is equal to the number of protons, which is also 11, and it is equal to the number of electrons. So number of proton, atomic number, and number of electrons, they are all the same. But when sodium loses electron, you have 2, 8, 1. So it can lose this electron in order to obtain stability. Now, when it loses that electron, it becomes Na+, which you call a cation. Now, this Na+, we have a configuration of 2, 8, which means that the atomic number still remains the same. The number of protons still remains the same. But what has changed? The number of electrons. So it has 11, but not equal to number of electrons. So the number of electrons is 10. I hope you understand that. So it is the number of electrons that change, not the number of protons. Because if you change the number of protons, that means we are no longer talking about sodium. If I change the number of protons to 10, I'm moving on to neon. That is not sodium. I hope you understand that. Let's look at another example. If I have chlorine, this chlorine atom has atomic number of 17. That means the number of protons is 17. The atomic number is 17. But what is the number of electrons? Since it is neutral, that means the number of electrons is also 17. Do you understand that? Now, let's look at chlorine ion. Since it's carrying a negative charge, what does that mean? Carrying a negative charge means it has gained one more electron. So that means the atomic number, it is still 17. The number of proton is 17. The number of electron is what now? 18. Can you see that? That is for an atom that has gained electron. The one that has lost electron has 10 electrons. So you can see that. Now let's look at this. You can determine this. Aluminium, Fe2 plus, Mg2 plus, Ne. So you can determine their atomic number, the number of protons, the number of electrons, as you can have them in any case. So let's have that. Now let's have a negative ion to O2 minus. So try the number of protons, the number of neutrons, electrons, and so on. Now, I've taught you how to determine the number of neutrons from the first class. So now let's move on to the next thing. When you see hear the word nucleons, it is like the particles that are found in the nucleus are called nucleons. So the number of protons and neutrons that are found in the nucleus are collectively called the nucleons of an atom. They are found in the nucleus. So atomic number, like I said, is the number of protons that are found in the nucleus of, the number of protons, yes, that are found in the nucleus of the atom that determines the position of the elements on the periodic table. That is what we call the atomic number. Now, when you talk about nuclide, an atom with a specific mass number, an atomic number indicated, that is what we call a nuclide. If I have this now, this is carbon, let's say carbon 12, atomic number is 16. I have carbon 14, atomic number is 6. So when you look at these two atoms, carbon 12 and carbon 14, they are atoms of the same element. But do they have the same mass? No. This has a mass of 12 and this has an atomic mass of 14. Which means these atoms are not properly the same in a way. They don't have the same physical properties, but they exhibit the same chemical properties. Now, when you look at this atom, if I write something like this, this is not indicating the mass number, nor indicating the atomic number. Now, that means I do not know the composition of this atom. Now, when you look at the one indicating the mass number and atomic number, these are called nuclides. So an atom with a specific mass number and atomic number that you know, it's called what? A nuclide. Now an isobars, when you hear the word iso means the same. Isobars, isotones, isoelectronics, isotopes, it means the same. Something is related. So isobars means they have the same mass number. There are some atoms on the periodic table. There are some atoms you have that exhibit the same mass number. They are isotopes, though. These isotopes exhibit the same mass number that you have. So isotopes of different elements, that's what I'm trying to say. I don't mean that isotopes have the same mass number, no. Isotopes of different elements. So you can have, let's have calcium 40, atomic number 20, and potassium. Normally potassium has a mass number of 39, but the isotope has a mass number of 40. So, and the atomic number is 19. Now you will see that these are nuclides of different elements, but they have the same mass number, so they are called isobars. Now when you're talking about isotones, you could have noticed isotones, neutrons, so they have the same neutrons numbers. There are some elements that have the same number of neutrons. So let's check that out. Let's have nitrogen 14, atomic number 7. Let's have carbon 14, atomic number 6. Oxygen 16, atomic number 8. Now, looking at what we have here, which ones are isotones? The number of neutrons for this is equal to the mass number minus the atomic number. So the number of neutrons is 14 minus 6. So the number of neutrons in this case is 8 for this carbon 14. Now for oxygen, the atomic number, the number of neutrons is the mass number, which is 16 minus 8. The number of neutrons is 8. Now when you look at these two, but for this number of neutrons for this is 7. Now compare the number of neutrons, this and this, they have the same neutron numbers. So having the same number of neutrons, they are called isotones. That is what we have here. Now when you talk about isoelectronics, isoelectronics are ions or atoms with the same, I said iso means the same. So with the same number of electrons, so they can have the same electronic configuration or exhibit the same number of electrons. So those are called isoelectronics. For example, if I have neon, the number of electrons for neon is 10. If I have sodium, Na+, you remember we did this, the number of electrons is 10. If I have magnesium, the number of electrons is 10. If I have aluminium, the number of electrons is 10. Can you see all these ions and this atom, they are all exhibiting the same number of electrons. So they are called isoelectronics. Now their electronic configuration is 1s2, 2s2, 2p6, 3s, 2 pieces, so that is 10. So they have the same number of electrons and the same electronic configuration, so they are called isoelectronics. So I will talk about the rest